expansion. Oh, I'm. Namaskar. Do you see the screen?
Yes, we see the screen. You can enlarge it, I think, sir. A little, if you can enlarge from your side. Yeah, no, it's correct. We can see the screen. Not a problem.
Now, how the periodicity comes actually. Recurring decimal you have seen yesterday about 1/19, and it goes up to 18 digits. How it is happening. So likewise, this periodicity of various recurring decimal is actually related to the factor of all these what's called repeat nines numbers. 9, double 9, 999, 9999, and so on. Since 3 and 9 are periodicity have periodicity 1 is known, periodicity because they are the factors of 9 itself. So periodicity of other numbers will depend upon the factor of being of this form. 10 to the power 9, 10 to the power n minus 1 divided by 9, divided by 111. So
yeah, there is a voice there. The voice is just echoing. You just check your side because you are in two numbers, please, because your voice is echoing.
I'll mute it completely. Now it is okay?
Yeah, now it's correct. Now it's okay.
Now these are the 111 and so on. This is getting factor of that. So that way, and moreover, when the even numbers of ones are there,
again it's echoing, sir. Some
bell is ringing, no? Time to time. So this is called repeat 9 numbers. The repeat 1/9 of that is repeat 1 number. So these also can be the factor of why about the periodicity of the numbers. And now when we factorize this even number of repeat unit numbers, means that numbers of ones will be even. It can be again factorized into a smaller one number and what is called hollow number 101. There will be zeros in between. So likewise, there will be also factors of this kind of form, which is named as jumpy numbers, 90909091, like this. So by analyzing that, I will have a quick go through this one. So a repeat number is this and hollow number. So by this analysis, there is a detailed analysis about these things. This is for a little higher who can participate into this. We find that different periodicity of the recurring decimals are like this. 9 on 3, these are periodicity 1. Then 99, 33, the periodicity 2. Then 37, 27, 13, all these things are, the 37, 27, these are periodicity 3. 101 is the only one which is periodicity 4. Now there will be this 5 numbers of 9, 99999. As if we factorize that, it comes to 41 into 271, and so 41, 271, and 3 times of, because 3 is also there, 3 and 9s are there. So 3 times of that, 123 also periodicity 5. 6 periodicity has so many numbers, 7, 13, 21, 39, 63, all these things. 7 periodicity has 239 and 4649 as the only two numbers which has periodicity, only two prime numbers are there. Prime numbers are shown in black, others are composite numbers are shown in red. So 8 periodicity, 73 and 137. 9 periodicity has this. So many, this periodicity are analyzed like this, how much periodicity for each of them. So yesterday I showed you that about 19. 19 has periodicity 18 because this 19 is a factor of 1 and 9 zeros and 1. This is the factor. So the factor is called hollow 9. So that way it is a analysis has been made. So that way analysis is made up to up to 50 analysis is done. Just wait and some. So with this small discussion, I come back to my presentation. I was discussing here. I started with here. Let's see. Before that, I discussed that if I want to do the using the Nikhilem method, how the different factors will come. It will keep on going, and there will be, in fact, I think it is 44 digits. I yesterday told 48 digits. I have to see. So whatever it is long, it can be sometimes that for 109 it is 108 digits. You cannot go like this. So this proper method has to be followed, and these are the two years, right? The Vedic online method. This actually this is a screenshot came from this copy paste came from Excel spreadsheet. Using Excel it can be done. Later on you can see how it can be done. Now how yesterday whatever procedure we discussed, did you follow it? Any problem was there? How it is being done? This one.
If anybody wants to respond, please raise your hand. If anybody wants to ask a question, no? If anybody has faced any problem yesterday. I think everything is fine. So please carry on, Gautam.
So how we started? Should we revise? CC Babu Garu wanted to tell something. Raised hand.
Yeah, if you can go through that this Vedic one-line method which you said yesterday. It was very easy yesterday, but then it vanished from the brain again. So
I see.
Yeah, if you can once say that, it will be nice.
Actually, randomly, let us do the exercise. I take a number.
Right.
Say start with 2. I'll double it. Always I'll keep in. It is actually sometimes it is. People say that easier to multiply than divide, isn't it? Most of us will feel like that. So 2, you multiply it by 2.
4.
Then again keep on multiplying. 8. Now 16. But when 16 comes, I put 6 here and I put 1 a little less than 1. Change these, I put like this. I will add it to this one. So 6 I double. 6 I become double, it becomes 12. But 12, 2 I write, 1 I put here. Again 2 double 4 plus 1. Sorry, it becomes 5. No, I'm sorry. Here is the right messed up. I'll again come. Here it should be it's 16. 16 into 12 plus this 1, 13. I'm sorry. It's 13. And 3 plus 6 plus 1, 7. This will be 7. This is 7, okay? 3 plus 1, 7. 7 becomes 14. 4 I write and 1 I put below. 4 into 2 is 8 plus 1 is 9. But there is nothing, no carry. 9 into 1, 9 into 2 is 18, like this. Again, 8 into 2 is 16, it becomes 17, plus 1, 17. This becomes, likewise, you go. Okay. Understand? I came back to 2. So it will again continue to like this. So I write all these things in reverse order. In this case, I have to write in reverse order. So I say here, I started with 2. So I started with 2. I ended up in 1. So I write 1. I put a 0 point, then 1, 0, 5, 2, 6, 3, 1, 5, 7, 8, 9, 4, 7. Even if I committed a mistake, when you understand the concept at least, no? 6, 8, 4, 2. Okay. So so this somebody can kindly note down this sequence. 1, 2, 3, 4, 5, 18 digits. Yes. So that means I didn't commit any mistakes. So it would have been something else. Now suppose I take a number 3 and with a carry 1. I keep on multiplying this by 3. Keep on multiplying this by 4. What will happen? 3 into 4, 12. Plus 1 is again 3. 12 plus 1 is 13. Again, it will be 12 into 4 plus 13. It will go like that. Isn't it? Similarly, I start with a number with a carry 2. I multiplied by 4. 6 into 4 is 24 plus this 2 is 26. Again this. Again I will get 26 like this. All 6, 6, 6. So there is a mystery behind all these things. This is that about this Vedic online method. Anything? Any reaction? So I start with this one again. I repeat. How did we do yesterday? 1 by 19. I started with say 1 here. I'm showing the opposite direction today. 1, and there is no, there is nothing carry here. So 1 multiplied by 2 is 2. 2 multiplied by 2, 4. 4 multiplied by 8, 8. 8 multiplied by 4 is 16. 6 I write, and 1 is carry. 6 again becomes 6, 12 plus 1, 13. 13, 6 plus 1, 7. 7 plus 7 into 2, 14, 14, right? 4 into 2 plus 1, 9. Like this way it goes. So therefore 1 by 19 is this one. And what I told yesterday, so you have to, suppose you have to know about what is the result of, say, 9 by 19. Where should I start? Here, where should I start here? 9. 9 I multiplied by 2 becomes 18. 8 I write and 1 I. This way it will go back and it will come back here, and finally it will end up here. So it becomes actually, or otherwise I could have started with 9 and divided it by 2. Becomes 4 and carry remainder 1. Whatever is carry in the case of right to left becomes the remainder in case of left to right. Isn't it? So this, anybody can start with the starting point of this one? 0 point how much?
Yeah.
First 4 digits at least.
There is a lot of disturbance on the sound. Maybe the air
Yeah,
sound is coming. Yeah.
It's echoing a lot, Gautam.
Echo. Actually, I'll put it. I'll better switch off.
Even the background noise, some vehicular noise and all is heard. Just see, you can count. CC Babukar, I made you the co-host, so you can remain unmuted or muted,
Yeah, thank you.
Because of the sound, I just muted everyone, that's it. You
Right.
can unmute and
Now,
anybody
are you getting the echo now? I switched off one.
Yeah,
Now it's okay. Now it's okay.
And if anybody wants to say something, you can all raise your hand and we will.
So please tell what is the first digit of this one?
Yeah, 9 by 19. First is 9. Then you said something.
No. But what will be the after 0 point? What should I write here?
0 point. We are not getting.
So instead of, I told you that instead of dividing by 9, you have to divide it by 19. You have to divide by what?
2.
What is the digit divisor for this one? 19. Ekadikana Purvena, isn't it?
Ekadikana Purvena. Is 20?
20 plus 20 by divided by 10, which is 2.
Okay.
So you have to do 9 by 2, isn't it?
Okay, 9 by 2.
Instead of 9 by 19, I do 9 by 2, but in a different fashion. What will happen? How much is the, I put a 0 point.
Okay.
And what is the result and what is the quotient and remainder?
8, 1,
9 divided by 2.
And you start multiplying, isn't it? 2, 9.
No. Here dividing. I mean, better to divide because this will go to left to right. Otherwise, you forget to again. Opposite. That also can be done. that will go in opposite direction. But let me see, let me do it by division from left to right. What is the first digit? 9 by 4?
Okay.
No, sorry, 9 by 2?
9 by 2. Not able to get.
It's 4, no?
Yeah.
Divide 9, it will be 4. But there will
Okay.
be one remainder will be there.
Okay, you are talking of direct division. I mean,
Direct
okay.
division, yes, yes, yes.
Okay, fine. 4.
4.
1.
And,
1.
and this term becomes 14. 14 divided by 2.
7.
Mentally you have to do very quickly. You tell me. Now 7 becomes
7 is 3.
3. Remainder
1. 1 remainder. 1 is again 5.
3, 13. 13.
Yeah.
13 is
6.
6.
3.
6. But remainder 1, isn't it?
Yeah.
Then
13 is 6 again.
no, 16. 16 divided by 2. 16 divided by 2.
4, 7.
16 divided by 2. 16 divided by 2 is
8.
8. Then 8 divided by 2.
4.
4. Please tell.
2. 2.
See, here it is.
1.
See, whatever I'm doing, I show. See, after 9. So 9 by 19 will be after 9, it comes here like this. So once suppose you have in the list already, after that, after 1, it goes to this 0, 5. And so on. In case of 19, it is full cycle. That is happening because this way. Otherwise, it will be different. So it is also possible.
Yeah.
It is also possible other way around. Say, I'll tell you. Here, I told 9, no? You have to, but it is you have to mind it. If you multiply, it will be from right to left. So start with 9. 9 into 2 is 18. 8 I write and 1 I carry. 8 into 2, it is 16 plus 1, 17. 7 into 2, again 14 plus 1, 15. 5 into 2, 10 plus 1, 11. 1 into 2, 2 plus 1, 3. 3 into 6, 2, 6. 6 into 2, 12, 2 I write and 1 I carry. 2 into 2, 4 plus 1, 5. This will go to opposite direction. Again, it will come back. Whatever you do, it will come back to the cycle and will end up here. It will end up to 9. So you know that this is you have to stop just before that. In case of left to right, it will go like this by division and by taking the remainder. And in case of opposite direction multiplication, it will be you have to take the carry and go to write the carry, and you have to add, you keep on adding the carry.
Okay.
Both the methods are all right. And wherever you do, in whichever part you break, you see that after a cycle of say 9 digits in the cycle, it will be 9's complement. In case of 1 by 19, I have seen that it is 0 and 9, 5 and 4. So it will be always 9 away will be always the 9's complement in this case. Okay.
This method is only for division by 19 or?
No, it will be any fraction with denominator ending in 9.
Okay. Okay. Can we have one more like
Yeah,
one,
yeah.
one 9
One
by
more.
29, 29?
Yes, yes. So these are actually, I told you by guessing how much it can be done. So yesterday I gave the exercise to all of you.
Right.
Anybody tried these things?
Oh, we didn't try this.
See, 11 by 19. Suppose 11 by 19 we take. Here actually it is not shown fully with remainder. 11 by 19. What will be the starting point? 11 by 19. What is the starting point? If we know the starting point, all others are here already in front of
11 by 2,
0 point how much first?
0.5.
See, this is the 11 is here. Actually. See, this is the 11. So we start it here. Starting is here. So I write 0.5. It will go like this 5, 7, 8, 9. Okay.
Oh.
5, 7, 8, 9, and so on. It will come back. It will come back to this 1. On the other hand, if I start in the right to left method, I could have multiplied by 2 and add this 1. So it will go to this way. 1, 3, 6, 2, and but you have to write it in opposite because it will come in opposite, right to left. That you have to only take care.
Okay.
So this is about 119 and all. So anything by 19 will come to the same cycle. Okay. So this feature of this cycle, being in a cycle, will never come when you do either use conventional method or the Nichilam method, even in Nichilam method. In case of now come to 1 by 29. In case of 29, what should be the digit divisor? Digit divisor will be that 1 more than previous again. Previous of 9 is 2, and 1 more is 3. Also by this way also you can do. D plus 1 divided by 10 is 29 plus 1 divided by 10 is 3. Divided 1 by 3 is quotient is 0 and remainder is 1. Makes it 10. So 10 divided by 3 again. Quotient is 3 and remainder is 1. In 13, this becomes 13. 13 divided by 3, quotient is 4 and remainder is 1. This way it goes. Q and R combination, I will written here 0. 0 in 0 divided, sorry, not 0, it is 10. I started with 10 by 90. Sorry, 1 by 29.
1 by 29.
1 by 29. If first is becomes 0 and 1 is remainder. It becomes 10. Okay.
10 is
then divided by 3. 3 is the remainder, 3 is the quotient and 1 is remainder. Okay. And it becomes 13. 13 by 3. 4 and remainder 1. 14, when I divide by 3, 4 becomes the quotient and 2 becomes the remainder. 24, it becomes 8 and no remainder. 8 divided by 3, 2 and remainder is 2. So 22 divided by 3, 7 and 1 is remainder. This way it goes and we'll come back to here finally. So 1 by 29 is this one. On the other hand, I could have started with 1 again. The same thing I can start 1 multiplied by 3. 3 into 3, 9. 9 into 3, 27. 7 I write and 2 I write in a small. This is carry. 7 into 3 is 21 plus this 2, 23. Again, at 23 write in this form. 3 into 3 is 9 plus this 2 is 11. So you see that this is goes like this in opposite direction also. You want to try to understand?
We'll have to physically work, then only we can get it.
Okay. The procedure is same. Only thing is that you have to find the digit divisor by putting this method.
So for 29 it is 30, and for 39 it is 40, etc., etc.
Here the repeats in up to 28 numbers. What you tell?
No. If it is 1 by 39, then we have 1 by 40, and so 4 is the multiplication factor or a division
4
factor.
is the multiplication. 4 is the multiplication or division. Division from right to left to right, and multiplication in case of left to right.
Okay.
So here also, suppose I guess for another one. It is because it is full cycle. This is only applicable for full cycle. Suppose I want to write 13 by 29. Anybody can any guess that where should I start?
13 by 29 is 3.
So 13, basically 13 by 3 I will be doing. We are starting with 13. Or want to do left to right or right to left? Okay.
Multiplication.
Multiplication. So 13 by 29. So 13 I start with. So I have to multiply what by what?
3 to 13. 3 into 13.
Yeah, 3 into 3. And then the 13 actually is, this is carry. So plus 1.
Okay.
3 into 3 plus 1 is 10.
10.
Again I write 0 and carry 1. 1 into 0 plus 1 is 1. 1, 3, 9 this way. You find out where it is. 13 is here. You find out 13, where is 13? 13 is here. This is the 13. So it becomes 0. 0 again becomes, as I told you, 1, 3, 9, 7, this way. But you have to write in opposite direction. On the other hand, if I 13 I divide by 3, it becomes 4, remainder 1. So basically 13 by 29, in whichever way you do, it will be this one.
0.
After that, this 13 is, you see, after that 0.4 double 4
Okay.
8275
Yeah.
275 this one 0 point here I put the point 0 0.44827586 and so on 13 by 9. Okay, you just practice it tomorrow again. Maybe you please see it today.
Right.
You please complete these exercises I had given. How much this both for this 19 as well as 29. You please do these exercises, okay? So that now you will understand that, okay, sir, you understood this,
Right.
how it is coming from. Okay. Now I come to anything n by a9 in this forms. A is any digit, not a into 9, but a digit. For fractions of the form a by 9, a9, we start dividing n by a plus 1. We start n by a plus 1. A can be even more than 1 digit.
Okay.
So it can be 119. In that case, I have to start divided by how much? In case of 119, we should divide it by what?
12.
12. So you have to do by 1, start by dividing by 12. This way. So I have shown here that from Excel spreadsheet, I didn't do it myself for so many things. So it can be multi-digit address, as I told. Here this A can be like this. A can be multi-digit address. So 29 by 59 will be like this. We divisor is 6, so I start with 29, divided it by 6, comes to 4 and remainder 5. And then it becomes 54. So it becomes divided by 6 is 9 and remainder 0. And if divided by 9 divided by 6 is remainder 1 this quotient 1, remainder 3. This way it goes. It comes up to 58 digits. In case of 59, it equals 58 digits total here. And I put this dots on that. Now let me see what is the reason. How by a simple basic online method we are getting that fraction property. So it is about today Akalai is not there, no? Any mathematically oriented person are there in this group? Can appreciate this one.
I think Yagna Narayan.
There will be so many. See, it is a binomial expansion of 1 minus x to the power minus 1. Means 1 by 1 minus x. So it is,
Sir, you two addressed na? Yesterday. You can all come mathematical.
Pardon? Madam, you can come back again.
Mathematically, who could do means Yagna Narayan Sharma ji and doing,
okay. But actually, this binomial expansion is basically a plus b whole square. Here, everybody knows. Okay. So there is this thing that suppose I do 1 plus. So you know all of all know, no? A
Right,
square
yes.
plus 2ab
Plus b square.
plus b square.
Right.
This is called binomial expansion. Anything. And when it becomes to the power 3, 4, etc., there will be a particular formula is there that instead of 1 a, I write I write 1 plus a. Instead of b, I write do not write b, but in case of b, I write this one. So there is a formula. So this becomes 1 plus 2a plus a square. So here you see that the power of a will be there and a square will be there. Suppose I do cube 1 plus a whole cube. It will be 1 plus 3a plus 3a square plus a cube. In fact, a plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube. But here it is a, instead of b I wrote a, and instead of a I wrote 1. So it takes in this form. So there will be always powers of this whatever is here in the second. This will be power, and 1 has all the powers of 1 is 1 only. So therefore, you do not see here, only you see that powers of the other one is increasing.
Yeah.
But in this case, so this is a kind of expansion of the this binomial expansion in case of to the power minus 1, negative 1. It has been seen that 1 minus x to the power minus 1 is 1 plus x square plus x3. It goes on to the provided there is a condition. It will not go to infinity like this. It will provided it is less than 1. X should be less than 1. So it will go like that. And but so therefore, if I take x common and keep on making x common, if I make it becomes again the same expression. Even I put this 1 plus again x common, so this will become like this. Same thing. This same thing will come back because it goes to infinity. So likewise, it can go to infinity. Or you always take this 1 by x and so on. So in case of this of the form 1 by 19 or 1 by 29, 1 by a9 of this form, this becomes 1 divided by 10n minus 1. So this 10n this 10n minus 1 is this one, 1 by 10n and 1 by this one. It will go like that. Then the most clearly it is in the next slide. You will see it is like this. Okay. This is actually, if we put n as 1, this becomes 9. N as 2, it becomes 19. N has 3, it becomes 29, this way. So how it goes, the binomial expansion goes like this. So I do it, and finally, it after these steps, it comes to like this one. So I divide 1 by 10. And actually, mind it, we are dividing by 2, but actually speaking, we are dividing by 20. Because when I throwing that particular thing in the next digit, becoming it is equivalent to being divided by 10 one again. So it becomes dividing by 20. So we're dividing by, when we are dividing by say 1 by 19 here, actually this is say n is equal to 2. So I put n is equal to 2. So it becomes 1 by 19, isn't it? 10 into 2 is 20 minus 1, 19. So actually, instead of dividing by 19, we are actually dividing by 20. This is 10n is 20. 10n means n is equal to 2, so 10n is equal to 20. So we are dividing by 20. And then we are keeping that digit. And again, there is some remainder, and we are again dividing it by 20. Again, some remainder, some result is, we are putting the result, but the remainder, we are again dividing by 20. This is the logic of this one-line method.
Okay.
Coming from the binomial expansion. Wherever there is some action is happening, there must be some algebraic background. So this is to be understood. Now we come to, you may say that you are talk only of that of the form 19 and 29 and so on. What about others? Now I want to say that it is in something ending in 1, 3, or 7. We have to multiply both numerator and denominator by 9, 3, and 7 respectively. So 1 into 9 becomes 9, 3 into 3 becomes 9, and 7 into 7 becomes 49, which is ending in 9. Something ending in 9, anything you will write, suppose 13. Suppose 13, I have to write 1 by 13. What should I do? Is equivalent to, it is 3 by 39.
Oh, yeah, 3 by 39.
Here I showed that it is 1 by 7.
Okay.
So in case of 7, I have to multiply by 7. It is 7 by 49. Say 1 by 17, I have to write. I have to evaluate. So it is become it is 9. Sorry. No, sorry. 7 by
119. Okay.
So in case of anything ending in 7, you have to multiply by 7. Anything ending in 3, you have to multiply by 3. Anything ending in 1, multiply by 9. So this way I erase. Thus 1 by 17 becomes 7 by 49. We start with 7 and divide it by 5. Why? This 4 plus 1 is 5. So 7 divided by 5 becomes 1. Remainder 2. This 21 divided by 5 becomes 4, remainder 1. Again 14 divided by 5, remainder quotient is 2. Thus, and plus 10 plus 4 is 14. And again 42 is 8 and remainder 2. 28 is 5 and remainder 3. 35, it becomes 7, again comes back to 7, and so therefore 1, 4, 2, 8, 5, 7. On the other hand, I keep on multiplying 7 in case of, here, not by 1. 1 by 7, we cannot start by 1, because it is basically it is 7 by 49, so we have to start by 7 and multiply it by 5. 7 will be the last digit. You have to always note down the last digit will be, see, last digit. So last digit have to start from here.
Gautam, just a minute. If you go back to the slide, wherein you have 7 by 29.
1 by 29.
7 by 49. wherein
Oh,
we
yeah.
said 7 by 49 is 7 by 5.
Yeah.
Yeah, here 7 divided by 5 means 5 ones are 5, carry 2, then 5 ones are 5,
Carry
4.
two is,
How did this carry 1 come by the side of 4?
because it's 21. No, 20 divided by 5 is 4. And but it's 21, so carry is 1. No.
Okay, just a minute. So 5 ones are 5, carry is 2, and then 20.
21.
Okay. Acha, you have to add this number, the side number.
No, add in case of going to right to left.
Okay.
It is a remainder. Remainder will write in a small small one. What is called remainder while going from left to right in the division? It is the same thing as carry while going to right to left in case of multiplication. Okay. So here is 21. I divide by 4. I divided by 5.
Right.
So it becomes 4 and carry 1. This is 21, no?
No,
21 divided by 5.
how did you
Quotient
get
is how much?
21? Because see, 7 by 5, one front and 7, 5 ones are 5, and 7 minus 5 is 2, so 2 is carried. Okay, then 5 into 1.
2 is remainder. 2
Okay.
remainder will be
Okay, got it. Right, got it.
this whatever is the remainder, it gives you the tens digit. So it becomes 21.
Right. Okay.
So it becomes 4 and 1. So quotient is here. Quotient is 4 and remainder is 1.
21. Okay.
Okay. What
Right.
I was telling? Yes. Last digit. I was talking of the last digit. I come back here. So always I told you already. The last digit is actually in case of 1 by 19, 2 by 19, 1 by 29. Whatever you start with, say n by this thing, your last digit will be that one. So, but
Okay.
here that was the we discussed already. See here 59 also. 1 by 59, 1 by 59. So here is I showed 29 by 59. See, start with 9. 9 is the last digit, but there is a carry. This 29. Carry is 2. So I have to multiply by 6. 6 9 is a
Carry is 5.
56. Sorry, 54 plus this 2 is 56. I write 6 here and 5 here. Again, 6 6 is 35 plus this 5 is 41. So the 41. So I write 1 and this carry I write here. So this carry goes on like this. Okay. But in this case, see the difference. In this case, in case of 1 by 7, my last digit is not 1, but it is 7. Because I multiplied by 7 in order to get 7 by 49. Actually, not 1 by 7. We are evaluating 7 by 49. We have to only keep in mind that one. So I start with 7 in case of 1 by 7. 7 and then I multiply by 7 becomes multiply by 5. Multiply by 5 becomes 35. 5 I write and 3 I carry. 5 into 5 is 25 plus this 3 is 28. I write 8 and carry this 2. So 8 into 5 is 40. 40 plus 2 is 42. I write 2 and carry a 2. This way it goes, that it finally goes back here. Suppose I want to have, say, 3 by, you tell me, how to write 3 by 7. How to
3
go?
by 7. 3
You
by
have to
7
full
is
cycle,
21 by
let's say.
49.
Eh?
21 by 49.
21 by 49.
3 by 7 is 21 by 49. Okay.
So
That,
it will last, my last digit will be 2, but there will be a carry 1. Where is that? Sorry, 21. No, I'm
21
sorry.
by
This
5.
is 21 now. Sorry, I told the opposite. 1 and carry 2.
Right.
This is. So we should
11.
come back to 1.
2,
1 and carry 2. This becomes 5 into 5 in the 1 into 5 is 5 plus 2 is 7.
7.
So likewise, it will come to 5, 8, 2, 4, and write it 0. Come back again 1. So 4, 2, 6, 5. So 21 with 3 by 7 is here. 4, 2, 5, 4, 2, 8, 5, 7, 1. Okay.
Gautamji, your screen is down. We are not able to see whatever you have written. You have to up the screen. Whatever you have written, we are not able to see. 0.426571.
How long you are seeing?
No. Whatever you have written, 0.4261.
Oh, this one actually. Okay.
Yeah, at the bottom,
I
we
write
are
here
not
again.
able to see. Right.
0.426571.
Yeah.
Because it carried 2 over there. So, so this is clear. This point is clear.
Yeah, others should
Now-
say that. You know.
I take another example, say 1 by 13. 1 by 13 is how much?
1 by 13. 3 by 39.
3 by 39.
3 by 4.
So it starts with 0, 7, 6, 9, 2, 3. But actually, this is actually very peculiar. No, this in case of 7, the cycle becomes ends in 6, 7 minus. Earlier also you have seen that for in case of 19, the cycle is up to 18. In case of 29, it is up to 28. But here you will find that in case of 13, it became comes back at 3, 6, because 13 becoming a component of 999. I told you, no, 13 is a factor of, in fact, factor of 1001. 1001 actually a factor of, this is actually factorized as 7 into 11 into 13. As a result, if I multiply it by 111, so 111 multiplied by 1001 is equal to 11111, 6 numbers of 1. So 13 becoming a factor of this actually, because 13 is a factor of this one, 1001. So 13 is also a factor of this one. And if I multiply by 9, it is all 999. So 13 is a factor of this also. As a result, its periodicity cannot be more than, it is 6, cannot be more than 6. But say 11 is also a factor of this one. But 11 has periodicity 2 because 11 is also a factor of 99. This 99 again is a factor of this one. But this is the shortest. 7 is not a factor of 99. Neither 13 is a factor of 99. Whereas 11 is a factor of 99. So it has periodicity 2. But these are periodicity 6. So this has to be understood. So then come back also. We suppose we do not innocently do not know anything. We start dividing this 3 by 4 in order to get 1 by 13. So it comes back after that 0, 7, 2, 3 by 4, 0 and carry 3, remainder 3. 30 is divided by 4. It becomes 7 and remainder 2, 27. 27 divided by 4 becomes 6 and remainder 3. And 36 divided by 4 is 9. 9 divided by 4 is 2, remainder 1. 12 divided by 4 is 3. Again comes back to 3. Again 3 divided by 4, it becomes 0 and remainder 3. So this becomes this one. Okay. But what happened to others? So you'll find that therefore, for 13, there are two different cycles. Suppose I do 2 by 13. I erase and freshly I do. Tell me, I in this small gap I do 2 by 13.
I think if you take a whiteboard, I think it is clear because in the sidelines we are not able to get it. You take a whiteboard and then start the example. Yeah, thank you.
So I write, I want to do 2 by 13. You tell me how to go about it. 2
by 13 is 6 by 39.
6 by 39. Okay. How to go about it now?
6 by 4.
So I have to start by 6 divided by 4. I put a different notation to know that this kind of division, as if we are doing it in fractional form, and these kinds of division means we are doing in the quotient and remainder. Okay.
Okay.
So 6 by 4, so it becomes 0. Sorry, it is how much it is? 6 by 4 is 0. 0. 6 divided by 4, 1.
1 and 2.
Remainder.
Carry 2.
And again divided by 4, 21.
21. 5, 1.
5, 15.
15 is 3, 3.
3.
3, 3. 33 is 8, 1.
8, 1.
18.
4.
4, 2. 24. 6, 0. 1, 2.
Again.
6, 0 and 1, 2.
So it becomes basically, we came back to 6, 0. This is also 6, 0.
Right.
This is 6, 0.
1, 5,
So
3, 8,
1,
4,
5,
6,
3, 8,
1.
4, 1. So this is, you see in case of 1 by 13, we got it different, no? So these are two cycles.
Right. Right.
So from here, actually, what are the things will come from here? You see, from here, these are the number will come. It will come to 21 by 39, 15 by 39, 33 by 39.
Oh, okay. Oh,
39. 24 by 39 and 6 by 39. are 7 by 13, 5 by 13, 11 by 13, 2 by 13. Rest are there. Rest means 1, 3, 3, 4, 5, 6, 7, 8, 9, 10, 11 is here, 12. Rest of the things will come to other group. This one, this group.
You mean to say all these things that you have said right now, 7 by 13, 5 by 13, 11 by 13, 6 by 13, all this will have the same answer, you mean?
Same, not same answer. Rotating answer.
Rotating answer, okay.
This here, actually here you see, this is the this is 10 by 13. This will lead to 10 by 13. This 10 by 13 will be 0.76923 and so on. This will lead to 27 by 13. 27 by 13 will come from 6923. So 29 by that means 27 by 39. I'm sorry. This is 30 by 39, 27 by 39, 36 by 39, 9 by 39, 12 by 39, and this 3 by 39 which we started. So after that it will start. Okay. So you also do the same exercise, that how much about this one, what is the starting from of each of them. Similarly, 1 by 17 becomes 7 by 119, so that it becomes actually 7 divided by, so 7 has to be divided by 12. So I didn't do myself, but done it by Excel sheet. So here is 16 digits I have. So here you see all are remainder, quotient and remainder are shown here. In 12, there can be remainder from 0 up to 11. So 11 remainder also is there. So on. It will conversion process. You have to do in cool mind, because the time is very short. I cannot do all of this. In cool mind, in a result time, you please evaluate some of these. Say you take, for example, I give you exercise. So tell me, you do for, say, please note down, it's coming, yes. So suppose you do by, say, 10 by 17. You please evaluate, say, 10 by 17. Or say, right, with 10 by 13 you can do. You do, say, say 15 by 17 you can do. Okay. This please do that like this. You can do also 8 by 17. So this way, you please, whatever you do, you start. It should be sometimes it should be different also. It has 16 digits, so you can 2 cycles. So it is 1 cycle. In case of 17, it is 16 digits, means 1 cycle, and in case of 13, it is 6 means it is 2 cycles. Now, about 39, the very interesting thing is there. About 39, I got this 2 cycles. No, there will be 6. It is periodicity is 6. 6 into 6 is 36. This could have been up to 38, but it is actually up to 36 you get that result. But there are 2 more which are very peculiar. I start with, in case of 13, somewhere I do 13 by 39. You see what happens?
13 by 4.
13 I divide by 4.
Yeah.
It becomes 3.
1. Yeah. 1.
Remainder 1. Again
4. 3,
So it
3,
becomes
1,
basically this one
3, 1, 3, 1, 3, 1, 3, 1.
always. Because 13 by 39 is nothing but 1 by 3, which is
Yeah.
actually 0.3. That is the reason it is coming like this. Anyway, these are to be, so those two, 13 by 39 and 26 by 39 goes. The rest, those 36 is divided into 4, divided into a group of 6. So these are the detail about detail, those who are interested. So I was here. N by A1. Now this very peculiar thing comes actually. Here I was multiplied. I was in case of 39, 7. I was doing 7 by 49. It's still manageable. I keep on dividing by 9. I dividing by 5. In case of 13, I divided by 4 because 1 by 13 becomes 3 by 39, and 3 plus 1 is 4. I divided by 4. Is clear?
Right.
In case of 17, it becomes slightly big. I become slightly annoyed because I have to divide by 12. So 7 by 119. So 11 and 12. So still I managed it, but not very happily. But what happens? I do 1 by 29, 1 by 31. So I 121, 1 by 31, 1 by 41, and so on. It is ending in 1. So 1 by 21 becomes 9 by 189. So I wanted to avoid dividing by 21. I end up dividing by, I'm sorry. I end up dividing by did I save anything? Did I save much? I wanted to divide by 21, by end up dividing by 19, because when I multiply this 21 and go on, becomes 189. That's constant is unstable. Do you hear me?
Yeah. We are able to hear you.
I showed that my connection is not stable.
No, it is there, but then there's some background.
Now 1 by 21, so 9 by 90, 189. And what is the digit divisor? 18 plus 1. 18 plus 1 is 19. So it didn't say much. In case of 1 by 31 becomes 9 by 279. 9 by 279. And it becomes amounting to divide
28.
by 28. In case of 1 by 41, it becomes 9 by 369. And dividing it amounts to divide by 37. It's not easy. Dividing by 19 or multiplying by, even want to go to right to left, multiply by 19, multiplying by 28, multiplying by 37. These are not easy actually. Now, so therefore, we again go to that binomial expansion. Let us see if this binomial could save us or not. So 1 by 21, 1 by 31, 1 by 41 are of the form of 1 by 10n plus 1. Earlier we had 10n minus 1, isn't it? 10n minus 1 we had.
Yeah.
Now it is 10n plus 1. So what is the binomial expansion of 10n plus 1? 1 plus x to the power minus 1. Now this becomes 1 minus x. Earlier we had all had plus. Now it is alternate minus, plus, minus, plus, minus, plus. 1 minus x plus x square minus x cube plus x4. But if I take common, is equal to 1 minus x, and again becomes 1 minus x, 1 minus x, because something in the in the this minus, automatically this minus and multiplied by this minus becomes plus, so it becomes x square. But again, this all this minus adds up to this one. When this comes to 3 numbers of x, becomes again x cube is minus x cube. So this way it automatically takes care of taking minus, minus, plus. So my concern is that only negative is there. That is important, that I have only negative will do for me. I get concerned with this negative. Don't it goes to infinity. Therefore, 1 by this 10n plus 1 is 1 by 10n. If you take common 1 plus 1 by n, and this finally becomes always this, but this is always becomes minus 1. It always becomes 1 by n. I'll tell you more clearly in this particular format. Earlier, so we had shown like this, except it was minus. Now, this is always this. This is always minus. See, minus. And finally, I come to here, like quotient and remainder. I'll keep on doing only quotient, remainder into 10 minus minus this thing, quotient. So if I do like that, and anything multiplied by that, it will be multiplied by that external. So I give you practical example of this one. So I start with 1 by 21. So for denominator of the form a by 1, we simply divide by a, but in the opposite, something different. Let us take the case of 1 by 21. Here, digit divisor will be eco here the digit eco not, I cannot do anything, or that in that formula it doesn't come. 21 minus 1 divided by 10 is 2.
Okay.
Or you can take directly that unity. I mean, accepting the unit, sorry, not unit, accepting the unit, the rest of the digits they can take. We proceed as follows. We have time, 5 to 15 more time, we can cover all this. We proceed as follows. 1 divided by 2 is, quotient is 0 and remainder 1, isn't it?
No. Yeah.
But earlier we did, it became 10. So 10 we divided by 2 and become 5. In order to get 1 by 19. You remember, no? Now, considering the binomial expression, you have to do 10r minus q in this case. If I do 10r instead of 10r plus q, 10r plus q, earlier we did. We did earlier, no? 10r q means basically it is a 2-digit number with r, meaning remainder as 10th digit. Here I do the opposite. I subtract it earlier.
Subtract.
It becomes like vinculum. It becomes. So as if your remainder is there, as if your quotient is a vinculum. As if, because of that minus factor in the binomial expansion. So 10 into 1 minus 0 is 10. I do not find much difference. Here also 5 is there. Earlier also we got. So 10 divided by 2 again, 5. We got 5 and remainder 0.
Gautamji, Pallaviji is saying could not understand this example.
Which one?
Yeah, this example, I think whatever you are telling now, you know. Pallaviji, you can ask your question. I'll unmute you.
Actually, I think it will become a little difficult. I gave another example where everything here it is slightly notation will be different. I come to this example. So I heard to always start by create. Better I do 14 by 41.
14 by 41.
Pallaviji, please ask your question.
Sir, just the change you're telling now, it is a bit confusing, like 1 by 21. So I did not get that plus wali cheez jo aapne isme change kara hai.
No, actually, they are actually 1 by 29 next step question. Next step, because here sometimes we get negative also. Very peculiar. In this fashion, positive and negative both had to be handled in a similar manner. I told you that in Vedic mathematics, we sometimes have like this. You know, vincula method, 3 and 1 actually should be above. Vinculum notation is equal to 29. No?
Right. 29.
we handle negative numbers as if in same in a similar fashion. In a similar fashion, in case of writing digit. In normal mathematician, if you put like this, they'll be just enraged. I've seen that. They'll be very angry. But in Vedic mathematics, it is allowed. Place in a place value is -1. So actually value is 29. Nothing to be, sorry, 29. 5, 3. It is actually how much? It becomes 47.
47.
47. So it is allowed, which normally it is we didn't do it. So we start with like this. Because this, the expression, binomial expression, that everything is negative here. See, all are negative. We are following basically this one, the last this one. In case of 1 by 19, and in case of anything by 1 by 21 or 1 by 14, I say 14 by m is equal to 14. 14 by 41. Suppose m is 14 and n is 4. So 14 by 49, 41 comes from here. So I'll just do this thing. 14 by 41 is a little easy. So we start like this. 14 divided by 4 is how much? 3.
3.
Remainder 2.
2.
So earlier we did, in case of 14, suppose had it been given 14 by 39, I would have done it 23, means 20 plus 3, isn't it?
Okay.
20 plus 3 would have done. But here we will do the opposite because of the minus
23.
symbol. 20 minus 3 will do. We will put a vinculum in each of them. Not while writing, but while evaluating. So it becomes 17. 2 and 3 vinculum becomes 17. 17 divided by 4 is 4. 4 into 4 is 16, plus 1 is remainder. So instead of 14, I call it 10 minus 4.
6 is 1,
6 divided by 4, quotient 1,
19.
and remainder 2. So instead of 21, it becomes 2, 1 vinculum, and becomes 19. I put it in a bracket to understand. I would not have written it. Then 19 divided by 4 is again 4, remainder 3. So 30, again it is vinculum. So it becomes 26. 3 vinculum 4 is 36, 26. 26, 16, it is 26 divided by 4 is 6.
And 2.
No. 34. 26. Oh, I have something wrong, no?
No. 26 is 20 minus 6, 14.
26 divided by 4 is 6, and remainder 2, no?
Right. You have written 1. That is 2.
That is just a printing mistake.
Right.
Typing
Okay.
error.
Right.
I can correct it.
20 minus 6 is 14. 14 is 4.
20 minus 6 is 14.
3 and 2. Again, we have the cycle.
Yeah.
20 minus 3 is 17.
This is the vinculum, and 14, and back to 14.
4,
So
1.
repeats.
Yeah.
So 14 by 41 is 3, 4, 1, 4, 6, and so on. It is a cycle as 5 because I had a discussion earlier, no? So this is because 41 is a factor of 99999. And that becomes very very long. That in case of 41, we could have expected up to 40 digits of repeating the cycle, but it is only 5. That means 8 different cycles will be there. There will be 8 different cycles. Something 3, 4, 1, 4, 6, and 14 by 14 by 30. No, something 13. I have not shown here. All different those 14s are all different cycles of 8. 8 different cycles of 5 length each.
Kaushikji, can we ask any, because it's 7:55, can we ask
Oh.
if anybody has any doubts, and then we can take up the class tomorrow? Will you ask? If anybody wants to.
Only thing is that this maybe for tomorrow I have to cover divisibility. Let me complete as many as possible. Sometimes we get like this. Then I come back to that discussion. 21. I was telling about 21. No. See the difference between 1 by 21. So I could have started with 9 and this dividing it by 19. Because 1 by 21 is 9 by 189. I told you earlier. But here I do negative method. This is by positive method, and this is by negative method. It comes back to same thing. Here only difference is that this 5 and minus 3 becomes 5, Vinakulam 3 becomes 47, and 2 minus 1 becomes 19. So how it comes actually, I explained it here in the previous one. So 1 by 2 is, quotient is 0, remainder is 1. Considering the binomial expansion, you have to do 10r minus q. I told you in the 14 by 41 case. Instead of 10r plus q. So 10 into 1 is 0, and this 10. So 10 divided by 2 is 5. So 5 is, it becomes quotient is 5 and remainder 0. Next is 10 into, next is 10 into, 0 into 10 minus 5. It becomes minus 5. And minus 5 divided by 2, quotient is minus 3. This has to be very clearly understood. Otherwise, this cannot be done. So this kind of thing is avoided actually. This some other very peculiar auxiliary some method is there in the basic mathematics book. Even this is not there. So they add by 9. Very peculiar things are done. So I didn't find it. I found it. This is more logical. So minus 5 divided by 2 is how much? Quotient is minus 3 and remainder is 1. Because minus 3 into 2 plus 1 is minus 5. Somebody may tell, no, I do quotient as minus 2 and remainder as minus 1. Remainder cannot be negative. You always remember that remainder is never can be negative. So as I told, basic mathematics, we handle positive and negative in the same negative numbers as same person. So it is minus 5. When you divide it by 2, it becomes quotient is minus 3 and remainder is 1. Minus 3 into 2 plus 1 is minus 5. Then, so far the result was 0, 5, and this 3. Next is 10 into minus 3 is 13. 10 into 1. 10 into 1. This remainder was 1. No, remainder is 1. Remainder 1. 10 into 1 minus of minus 3 becomes 13. Positive. 13 divided by 2 is quotient 6 and remainder 1. So it becomes 0.53 vinculum and 6. Next is 10 minus 4 is 4, and 4 minus this is remainder 1. So it becomes 10. 10 minus 6 is 4. 4 divided by 2 is again quotient is 2, remainder 0. So 0.5 and vinculum 3 and 6 2. Next 10 into 2 and this one. I think I've shown in the next one. Yes.
Gautamji, I think the time is over.
Yeah.
People have to.
This you just what to do. You all of you got this presentation, no?
Yeah, we got the presentation.
So only I think to study what is going to study, these actually coming directly below, so it may confuse you. So actually 1 by 21 is like this. You just please note down 1 by 21. You see it? Start with 0.0, 0.1, then 5, 0, 3, vinculum 1, 6, 1, 2, 0, and 1, vinculum 0, and after that it will repeat.
Okay. The cycle goes.
And this 5 vinculum 3 becomes 47, which is in the positive method, it directly comes to. This 5 vinculum 3 is actually 47. After all, the result should come same, no? And 2 vinculum 1 is 19. You please have a note. You all have a presentation. You try from here, and you try to understand about the negative method. What else more? What there? I'll just have a brief look. 14 by 31, 35 by 51. I put examples. Basic online method, A by 7. 7 you can have choice. See, 7 you have choice. Either I've shown that 56. I did 56 by 119. I'm sorry, 8 by 17. 8 by 17. Either you can do 56 by 119. 8 by 17 same as I multiply 7 both way. So it becomes 56 by 119, or it becomes multiplied by 2, multiplied by 3. So it becomes 24 divided by 51. So the 8 by 17 can be expressed as 50, either 56 by 119 or 24 by 51. When expressing as 119, you have to do positive method by 12. Here you have to do negative method by 5. So you can, this is your choice. But certainly it is ending in 1 will be very cumbersome in case of positive method. In case of 7, you have to still have your choice. So if this exercises some of you do, please do. It is given in the next one.
Right.
Exercise you are referring to 7. At least do first 10 digits, or slightly modify it. In both, you know, the both positive and negative method, no? Opposite direction.
Right.
Instead of first 10%, you can do past 5. First 5. Oh, sorry, something is happening. You can either do first 5 and last 5. Please do first 5 and last 5.
Okay.
In a cycle, all of them. So you try to do it, you will understand that you understand both the methods as well as you can arrive at the answer and finally you see from calculator. From calculator you can easily find the past 5, but from calculator you cannot get the last 5. It is very difficult because calculator displays only, I think, 11 or 12, something like that. Even very powerful one. Even in Excel sheet also you cannot display more than 11 or 12. But here you can display as many numbers as required. That is in the basic one-line method. That is the beauty of this. Now, at least last 5 decimals.
Okay.
The periodicity I already discussed slightly. The periodicity of how it is coming. I already showed you this one. Now, tomorrow I will come to divisibility, but we will slightly discuss, because divisibility also will take, because only one more day is there. So divisibility will take complete 1 day. If some time remains, I don't think, please you do these things. Initially I discuss something and then we'll switch over to degree. Okay.
Okay.
Okay, thank you.
Thank you.
Thank you.
Gautam.
Thank you.
Thank you. If
Thank you.
anybody has any doubts, they can get it clarified tomorrow also. Please do the assignment. Now now I request Vasundhara ji to tell the
But
prayers.
unless you do the assignments, you try to do yourself, your doubts will very difficult to be cleared.
Right. Thank you, Gautam ji, very much.
No,
Thank you.
अस्तु भगिनि स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महीं महिषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ
Dhanyavadaha, Vasundhara Didi. Now I request Jyoti Didi to tell the national anthem. All I request is to stand and complete the national anthem and sing the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे गाहे तव शुभ आशीष मागे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद.
Thank you, Jyoti ji. Thank you all. Let us all meet again tomorrow morning at this time. I'll close the session for today.